Young Albus Percival Wulfric Brian Dumbledore found himself in quite a dilemma. He had just settled himself into bed, only to realize that he, once again, had forgotten to turn off the lights. Now, ordinarily, one would think that this really isn't a big deal. Just get up and switch the lights off. But this was now the 13th night in a row that Dumbledore had forgotten. Muttering to himself as he once again left his bed, Dumbledore vowed to invent a device to ensure that he never had this problem again. The next morning, Dumbledore woke up still determined to find a solution to his light problem. He knew that something like this would be a huge undertaking, and despite knowing several of the greatest wizarding minds of his time, it would be difficult to fashion a device to his exact specifications. Therefore, he figured he would have to delve into the Muggle world and use some of their knowledge of engineering and science. Determined, Dumbledore flew over to the greatest Muggle engineering school of all time. Dumbledore recruited 4 of the most talented MSE 220 students to help him research this topic. During their research, the students discovered an amazingly cool, super chill material called yttrium silicate. Yttrium silicate is a compound made up of oxygen, silicon, and yttrium elements. Because it has a very high melting point and heat capacity, yttrium silicate has a special ability to absorb and trap large amounts of light without melting. The MSE students discovered that yttrium silicate exists as multiple crystal structures, but at most temperatures, it is face-centered cubic. In this structure, silicon forms interstitial point defects at octahedral positions relative to the yttrium atoms. The structure is highly packed, with an atomic packing factor of 0.74, and very few vacancy sites are present. Activation energy for vacancy or interstitial diffusion is very high, so diffusion only occurs at high temperatures. Yttrium silicate has high stiffness and a low thermal coefficient, which allows the material to absorb a large amount of light energy without melting or deteriorating. The MSE students found that it had a high bonding energy due to its high melting point. The phase diagram of yttrium silicate shows that it exists in the alpha plus silicon phase at room temperature and remains in this phase over a large temperature range. These phase diagram properties allow for a high heat capacity and a low thermal coefficient of expansion. This ensures that the yttrium silicate can absorb an incredible amount of energy and trap light. Happy with this new material, Dumbledore rewarded each of the MSE students with a lifetime supply of chocolate frogs. He returned to the wizarding world and designed a device called the Deluminator to cryogenically cool the yttrium silicate in order to guarantee that the temperature remained relatively constant. As a final thank you to the MSE students, he made sure that they received 100% on their whiteboard video project.